Welcome to Complexity Made Simple. My name is Paul Allen, and in this video's newsletter, what we're going to talk about is how a truth table works in a designed experiment. Now, this is as a result of somebody sending me an email someone who didn't understand how the interaction could be calculated in a DOE and how it would work properly. So let's have a look at the truth table in design of experiments. Now, to be honest, the truth table is the heart of a designed experiment. All the maths will only flow from the experiment because of this little innovation right here. It's known as coding. It's also known as a truth table. So we're going to take a look where it comes from, how it builds to create the interaction analysis, because variables often interact. We know temperature and pressure, for example, interact in a system, and we need to represent that mathematically. So let's take a look at the truth table. Let's see how it deals with the interaction. So okay, we're gonna just talk about the system. I'm gonna suggest that the system's got two variables. So we're gonna suggest that we're dealing with time, 5 seconds and 10 seconds, and we're dealing with temperature, 70 degrees to 90 degrees. Now that's the window in which we think we will produce items of value. Okay, so that little window there, the 5 and the 10, the 70 and the 90, that's where you're going to have to use your engineering skill to decide that. And then what we're trying to understand, let's say, is the effect of those two on the strength of the final product. So here are the inputs, here is the output, okay? This area here is known as your design space, because in theory, what we've just defined, if we draw it as a box, is potentially 4 test points. So we could go 5 to 10 on the time. We can go 70 to 90 on the temperature. You can see we're going to test that region. We're going to be testing strength as our output. And what we'll do, of course, we'll fill the box with maths so that I can predict any combination inside the box. That's the power of a DOE. Now, in theory, what this is telling you to do, of course, is make 4 tests. There's 4 corners on our design space. So the 4 tests would look like this. We'll call this factor A, by the way. We'll call that factor B. So let's have a look. Factor A would be, of course, time. And we would test 5 and 5, 10 and 10. B would be 70, 90, 70, 90. And that's that box that you can see there. Now, in theory, that looks very straightforward. Why don't we just do the 4 tests, do the analysis using 5 and 10, 70 and 90, and everything's right with the world. Well, there's a problem, the interaction. I can't analyze the interaction using real values. I could try and be clever. So for instance, I could try and multiply these together to create what you might call an interaction combination. What would that be? 350, 450, 700, 900. If I multiplied those columns. But these units don't make any sense. And this pattern here actually cannot be analysed properly. If you try and put maths to that column, it will create complete confusion. So there's something wrong with using real values. So what we do in maths is we substitute the real values for coded digital values, and you get something called a truth table, and it looks like this. So everywhere we put a to the low, I will replace it with a -1 value. When we put a to the high, I'll put a +1 value. Now this is known as coding. Then we go B, minus, plus, minus, plus. And then finally, now I have coding, I can work out an interaction column that makes sense. Because if I multiply these two together, two minuses make a plus. A minus and a plus gives me a negative. A plus and a minus gives me a negative. A plus and a plus gives me a positive. Now what I have is a properly balanced column. Now that's what was missing from this column. Balance means that I tested the interaction twice at the low, twice at the high. Twice at the low, twice at the high. Twice at the low, twice at the high. Okay, so there is the pattern that the interaction is being set at. Now what Pavel's question was about was, well, what happens if the positive and the negative are the wrong way round? So the way that Pavel was asking the question was as if when you have a variable going from positive to negative, that it's always going to go in this direction. And of course, this could be the AB interaction. And what he was suggesting was, well, maybe this would be the wrong way round. What if the reaction was the other way? Well, of course, what would happen is that the response would travel negatively, would travel in this direction. Now, with the first response, the coefficient in the equation would be a positive number. Let's say it has an effect of 2.8 on the strength. So it would be in the equation effectively as plus 2.8. But if it has a negative effect by 2.8, then of course the value will show up like that in the equation. But it's only by having the truth table, this is known as coding, and the whole thing is called a truth table, that when we make the calculations, the coefficients are true, but not only are they true, they will work. If you try and take this original pattern here and work out the coefficients for this pattern, number one, you'll get different numbers to this usually, and number two, it doesn't work. It won't work as an equation, because what you don't have is a balanced pattern. This interaction is not balanced with the other part of the table, whereas here, two negatives, two positives. It doesn't matter what the maths is doing. It will add negative coefficients to make the result go negative. It will add positive coefficients if the result goes positive. So there's two different things. There's the way you've set this, which of course is called positive and negative, and then there's the effect it has on the strength, and the effect on the strength can be either positive or negative. And what we're doing is we're looking at two different places in the system. One is the way we set the input, one is the effect on the output. And that's what the truth table is doing. It's giving us the ability to analyze the interactions, and it will analyze the interaction correctly. It is the only way it can be done. And this is why happenstance data doesn't work. It's why big data is so dangerous. Happenstance data is full of patterns like this. that are confusing and confuse the maths, tangle all the results up. A truth table disentangles all the results and gives you an equation that you can rely on. And that is the power of the truth table in a design of experiment.